So good morning, everyone, and it's a pleasure to be here and talk a little bit about our work in the frame of this cluster, which is related to trust assessment. So briefly about what is the driving theme of this cluster is we try to look after new methods and tools which we could use to support quantitative trust assessment. And the tools are based using simulation, modeling, and experimentation, or combination of those. And we start looking into the components, or assessing the components of this large infrastructure. So we look into assessing the power grid devices, but also into the protocols and applications which are running or executing on those devices. So this is in terms of components. On the other side, all these applications or devices operate on data which in one or another form represent state or reflect the state of the system. So one of important aspects is also to find a way to be able to determine to what extent we can trust the data on which we operate, which we use to make a decision in case when something happens in the system. So trustworthiness of this data or measurements which we get from the sensors in the system is crucial, and we try to find a ways of determining the goodness, is to say. Then we know that the failures in this kind of environments happen sooner or later. It could be due to accidental events or due to malicious activities in the system. So the question is now, how do we ensure operation of the system through failures, right? So how do we ensure the resiliency? To be able to do this, we have to have monitoring and protection mechanisms and algorithms which allow us to recover when something unexpected happens. And the cluster activities look into how to evaluate, how to measure the effectiveness of the monitoring or the robustness of the protection mechanisms which we put in place. Finally, we also pay quite a bit of attention into deploying new technologies or emerging technologies in the context of the power grid. Technologies such as cloud computing, we talked quite a bit today about this, and how do we evaluate, how do we measure what are the security or reliability implications of deploying this technology in the context of the power grid. So the scope of this cluster is quite broad, and of course we do not pretend or we don't claim that we address all the issues and we answer all the questions, but we try to contribute to each and every aspect of what I have been talking about. So if we look into this if I look into this entire journey, which I started with TCIP in 2005 and until today, 2014, so quite a bit of time. And I remember that at the early stages when we were still supported by NSF, and then DOE and DHS came into play, we were initially, I remember we had this meeting with industry and we talked about do we really have a problem of security in this environment, right? So we try to find evidence of security threats in power grid. What is the nature of these threats? You know, how do we can approach, what kind of approach we can use to handle them? Then I remember we focused quite a bit, very quickly, on developing methods for hardening software and hardware. We realized that it was obvious that there are a lot of legacy devices and they will not be replaced at once. So they will coexist, or they will have to coexist with new coming devices. So how can we, make sure that this transition from older technology to new one is seamless, right? So how do we make sure that we still operate in this environment and make it more resilient? At that time, we also started to think about how do we validate, how do we measure the security attributes of this large infrastructure. And it wasn't easy. I remember we had the problem to find a common language with the people from power industry. And when we said network was one thing for us and another for the power people. And I think we are in this journey from 2005 to now, we changed the way in which we communicate, and I think that now we understand one another. And last, thing which I wanted to comment here is PMUs. They were, few and far between, right? There was early stages of deploying this technology. So if we look now the last few years, what we accomplished in these clusters, there's a number of technologies, approaches, and tools which we developed. Some of them, stay in academia, as to say, because we are coming from universities and from academia. Some of them we are trying to commercialize. And you have examples of both here in this slide. So the first one is NetAPT, which is a tool for automated analysis and identification of configuration problems in the power grid environment. And now it is a commercial tool, which is, there is a startup company, NP Network Perception, which made this as a product. You can buy it, you can use it. We put quite a bit, I think, effort and make quite a bit of progress in developing high-fidelity, high-scalable simulation and emulation platforms for security assessment in the context of power grid. And this was quite important because having high fidelity and good simulation tools allow us to analyze this infrastructure at scale. Not only that we can consider bigger configurations, but also we could do this with the sufficient accuracy so that we could trust the results which we obtain from simulation and say something about real environment. And there are other things which we also look into, and I don't have time to talk about each and every of the bullets on this slide, but I think that this entire journey, at least for myself, from early 2005 to until now, was very exciting and very revealing. So currently this cluster has 8 activities. I'm not going to talk about each and every of those. You can get all the details about what has been done or what we are doing in each and every of these activities during the poster session. Each of these has at least one poster which describes in detail the work, and you are welcome to come to the poster session and ask for the details and talk with the students who really do the work. So what are the current challenges which, from perspective of this cluster? We are, I think, still, if we talk about model-based assessment techniques, we are still need, better, more powerful models and simulation infrastructure, particularly when we want to bring simulation and experimentation together. When we want to combine those, when we want to make even more realistic simulation and modeling, we need to have a good way of parameterizing the models. And how do we do this? We have to obtain some real measurements or real data from actual systems or actual environments. So we need to also do more work on models which address the coupling between the physical and the cyber side of the system, and particularly take into account what kind of inaccuracies or uncertainties are introduced by the fact that we have these two so different pieces of components in one single system. On the experimental side, I think we need still to develop better methods for experimental assessment of those systems. To create, subsystems or configurations which mimic reality is not easy in the lab environment. And I think we made significant progress, but we need to still do more. Looking into PMU data, we have to understand, to what extent we can trust this data. What I mean by this is we know that the data may be corrupted, not only at the source, but also when the data are transmitted over the network to the data concentrators. To understand what corruptions may happen, what are the causes, so that we can eliminate them if possible, and if not, how do we compensate? And this is crucial to have this understanding if you want to use this kind of information for controlling the grid, right? And of course, today there was a lot of talk about using new technologies such as cloud or migrating to cloud, a lot of computation. And I think we need to understand well what are the security and reliability implications of putting computation or moving to the cloud. And I remember that a couple of years ago, when we mentioned cloud in the context of power grid, many people were saying that it may never happen. But it seems like that it will happen at fast speed, as to say. So I wanted to conclude with 2 slides about what I found as some of the emerging opportunities and challenges. And the 2 which I'm going to talk about were particularly of interest to me, and I think they are really challenging. The first one, a challenge I call control system devices on the internet. This is data from the recent, 2 years ago, 2 years old report from CERT on industrial control systems. And so the data relate not only to the power grid, but also other critical infrastructures and also manufacturing. And they found here an interesting fact that there are quite a number of devices which are directly facing internet, and devices which are providing critical control functions to these systems. Now, the point which I want to make here is that if these devices are penetrated, they create a gateway for the potential intruder to the entire system. Now, the question is whether these devices really need to face the internet, and why they are visible on the internet. So what we need a method to identify and to remove those devices from having direct access to the internet if possible. And I'm not saying that nothing has been done, but there is a lot of work going on, and I think that whatever was uncovered in this study, all the facilities which have this kind of devices were contacted and people were doing to address these issues. But as we know, we always learn something from this kind of things, but not quite enough. So I think that in the future we'll still have devices which are accessible directly from the internet. Then we need methods to be able to prevent anything bad to happen to the system. We need to detect quickly potential intruders before the system get damaged. We need methods to be able to do this. And if we have methods and tools to do this, we need to have a way to assess or validate how good we are doing. And the last slide which I have is another challenge which I wanted to mention, which is what I call broad spectrum of vulnerabilities to handle. And this is again data from the year-old study from CERT, when they report that there were 181 vulnerabilities reports from researchers and ICS vendors in 2013. 87% of those were exploitable remotely. But the more important thing which I wanted to point out here is that if you look this pie chart, if you look into type of vulnerabilities which were uncovered, they are not that different. They are at all not different what you see in the general purpose IT network, right? And you see that about 1/3, 33% of those are related to authentication. We still have weak passwords, or we have default passwords in many of those devices. So perhaps I think we should revisit, look at the application domains, look what we have been doing to protect general purpose IT infrastructures or large computing networks, and think about how we can adapt these methods in the context of power grid. Over the years, the infrastructure changed quite a bit. There is a lot of computerized devices, and perhaps some of the techniques which we are using in other environments can apply in the context of power grid. I'm not saying that we grab whatever somebody else is doing and we plug in directly in the context of power grid and it will work, right? It will require some more effort. So this is, these are the two thoughts which I had about emerging, kind of problems and issues which I think are of interest, and this is what I wanted to start. If you have any questions, I would be happy to answer.
So thank you, Zbigniew. As we said at the beginning, it's very critical, we believe, to understand how to evaluate how well we're doing with these various security and resiliency controls. And you've seen we've made significant progress in that regard. We have tools that you can ask us for to do that kind of assessment, a whole array of them, but there are also challenges. Is there a quick question or two before we move on to the next overview?